The next set of identities are called the half-angle formulas. These will be derived from the reduction formulas by replacing our theta with a theta divided by 2. We'll first list these formulas, then we'll look at a derivation of one of them. First, we have that sine of alpha divided by 2 is going to be equal to the following. Then we also have that cosine of alpha divided by 2 is equal to the following. And finally, we have tan of alpha divided by 2 is equal to the following. Notice that each of these formulas have a plus or minus. And depending on where our angle alpha divided by 2 is located, we'll have a plus or a minus. So we'll see why this is important in examples, but first let's just go ahead and derive one of these. And let's derive the formula for cosine. So recall first that cosine squared theta is equal to a 1 plus cosine of 2 theta divided by 2. And if we replace our theta with an alpha divided by 2, this becomes the following. And I forgot, but there should be a 2 in this argument here. So now simplifying the right-hand side of our equation, we get that this is equal to a 1 plus cosine of alpha divided by 2, which on the left-hand side we still have our cosine squared of alpha divided by 2. And we can take the square root of both sides, and we get the formula that we want. We'll get cosine of alpha divided by 2 is equal to a plus or minus square root of 1 plus cosine of alpha divided by 2. So let's look at a few different problems using our half-angle formulas. In this first problem, let's find sine evaluated at 15 degrees. First, let's rewrite our sine of 15 degrees. And this is the same thing as sine of 30 degrees divided by 2. Rewriting this using our half-angle formula, we'll get that this is the square root with a plus or minus up front of our 1 minus cosine of 30 degrees divided by 2. Now, go ahead and note that we have our theta in this case is equal to 15 degrees. And this is equal to 30 degrees divided by 2. In either case, this is in the first quadrant, and our sine's always positive in the first quadrant. And this tells us that this is going to be equal to a plus square root of 1 minus cosine of 30 degrees divided by 2. Cosine of 30 degrees, we have our right triangle over here in the first quadrant with an opposite side given by 1, adjacent side square root of 3, and hypotenuse 2. So plugging this in, we'll get that this is equal to the square root of 1 minus square root of 3 divided by 2, all divided by 2. Simplifying this, we get that this is equal to the square root of 2 minus square roots of 3 divided by 4. And this is the final answer. Now let's look at a slightly more difficult problem. And this time we're given that tan alpha is equal to 8 divided by 15, and our angle alpha lies in the third quadrant. And what we want to do is we want to find the cosine of alpha divided by 2 and sine of alpha divided by 2. Let's first go ahead and note that alpha in the third quadrant is going to lie between 270 degrees and 180 degrees. So if we divide this by 2, then our alpha divided by 2 is going to be in between 135 degrees and 90 degrees. So this tells us that alpha divided by 2 is going to lay in the second quadrant. So this is going to be important when we apply our half-angle formulas. So let's go ahead and now draw the right triangle. Again, we know that alpha lies in the third quadrant. So here's our alpha. And we can form a right triangle from this angle. And what we're given is this tan alpha, which means this triangle has an opposite side length of 8, an adjacent side length of 15. And we can find the hypotenuse by using the Pythagorean theorem. So we'll get c is equal to 8 squared plus 15 squared, where we have the square root. Simplifying this, we see that c is going to be equal to 17. So we have all the information that we need to go ahead and evaluate cosine at alpha divided by 2 and our sine at alpha divided by 2. Let's start with our cosine first. So we'll have cosine of alpha divided by 2 is going to be equal to a plus or minus square root of 1 plus cosine of alpha divided by 2. And now, since cosine of alpha divided by 2 is in the second quadrant, and the only trig function that's positive in the second quadrant is sine, we want to choose the negative version. So this is going to be a negative square root of 1 plus cosine of alpha divided by 2. Now we can go ahead and evaluate cosine of alpha. This is going to be then equal to the square root of 1 plus 15 divided by 17 divided by 2. And simplifying this, we get that this is going to be equal to a negative square root of 1 divided by 17. Now let's go ahead and evaluate sine of alpha divided by 2. This time we have sine of alpha divided by 2 is going to be equal to plus or minus the square root of a 1 minus cosine of alpha divided by 2. Again, since we have alpha divided by 2 is in the second quadrant, that means our sine is going to be a positive number, and so this is going to be equal to the positive square root of 1 minus cosine of alpha divided by 2. And I just recalled that I made a small error in the last part of the problem, but let me head and move on, and then we'll backtrack. So cosine of alpha, again, if we evaluate this, this is going to be given by the adjacent, so 15, but this is actually a negative 15 divided by 17. So plugging this in, we'll get that this is the square root of 1 minus a negative 15 divided by 17 divided by 2. Simplifying this, we get that this is going to be the square root of 17 plus 15 divided by 17 divided by 2. This is equal to the square root of 32 divided by 34. So let me go back one more page. And the thing that I want to note is this value here, 15 divided by 17, should be a negative 15 divided by 17.